Hey, how's it going? Oh yeah, I still have my mask on. There we go. How's it going, guys? Helping you with boot camp graphing. So hopefully you watched those notes. That helps you or being in class or if you're an at-home learner. And now this is kind of part two of learning with graphing. So number one, real quick. We won't do them all, but we'll take a look. You can always do an XY table, but this is the intercept. And so that's where you're going to start if it's already in a slope-intercept form. And so we'll start at 5 because that's the y-intercept where it crosses on the y-axis. Then the slope is invisible there, it's 1. And so our slope is 1, but technically it's not just 1, it's 1 over 1. And so that means to go, what does that mean to do? It means to go up 1 over 1. Do you remember that? Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So then we're going to go up 1 over 1, up 1 over 1, and down 1, back 1, down 1, back 1. That wasn't too bad at all, was it? Number 2, again, is just up 1 over 1, up 1 over 1 with a y-intercept of what? 0. Nice. Y-intercept is 0. So the lines are pretty easy to graph there, but we'll do a little bit harder one here in a second if it lets me. There we go. Let's try one with a fraction. So this one's going to be down at -3 for the y-intercept, and then the slope is up 1 over 2, up 1 over 2, and then down 1, back 2. There we go. So there's our straight line for that one. Not too bad, right? Not too bad. It stays in line. There we go. There we go. Not too bad. Okay, awesome. Oh yeah, so standard form, remember, standard form, you're going to do an XY table thing. And you're just going to go ahead and choose, stop doing that. If it lets me, here we go. So we're going to do an XY table. And I'm just going to make sure that this works right. There we go. Okay. So then, there we go. So now we're going to choose 0 for x and 0 for y. And then solve for the other corresponding letter to get the x-axis and the y-axis. So if we choose 0 for x, that'll give us the y value. So 2 times 0, just plug in that 0 there. And so 2 times 0 is 0, just goes away. So now we're just left with this little equation that we're going to divide by -4, divide by -4. And so that goes away there. So then y equals 8 divided by -4 is -2. So we're going to go over on the x-axis 0 and then down -2, and that is going to be our y-intercept. Now we're going to go ahead and do the same thing, but this time we're going to use the y value as 0, so that becomes 0. So then this whole thing goes away, and now we're just going to divide by 2, divide by 2, and so 8 divided by 2 is 4. So then x equals 4, x equals 4. And so there's our graph. And so that's for doing it in standard form. Now we're going to show you parabola, parabola, parabola. And so let's see here. The easy one is like number 12, for example, because it's upside down. That's what the negative means, right? The negative means that the graph is going to go upside down. And it has a shift up of 9, because the parent function is just y equals x squared, right? So the parent function just goes like that. And so now what we're going to do is we're going to go ahead and we're going to, whoa, if it lets me ever do anything, ever. So technically it's not a smartboard. It is a true touch using smartboard software. Okay, so here it is. This is our parent function. We're going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to go ahead and flip it upside down. Bam! And so now we're at 9, upside down, and there's number 12. So that was just a shift up 9 and then go upside down. But what if it wasn't as easy as that, like number 9 or number 10? So number 10, you could use the formula, remember? So the formula, let's see here if it lets us do it here. No, thinner. I said thinner. There we go. There we go. Okay. So now we're going to use the formula, which is x equals negative b over 2a. And so our b value is what? Our b value is 3. And then our a value is the invisible 1 right there. There's our a value, just a 1. Okay, so now we use the formula. We go x equals negative b, which is negative 3, all over 2 times a, 2 times 1. Oh man, it's a fraction. That's okay. So negative 3 halves is basically negative 1.5. So x equals negative 3 halves. And so now we want to find the y value, right? So we're just going to go ahead and plug it in to the equation. So wherever c and x, we're going to throw in a negative 3 halves. So right here will be a negative 3 halves. And right here will be a negative 3 halves. Ooh, good thing we did this one. So then let's see here. There we go. Okay, so then what we're going to do is, so negative 3 halves squared, right? Negative 3 halves squared is going to be, what? 3 times 3 is 9 over 2 times 2 is 4, so 9/4. Then this is going to multiply. This is going to become, a negative 9 halves. And then a minus 10. How fun. Well, let's make everything in fourths. So we're going to times by 2 to turn that into fourths. This is 10 over 1. We're going to times it by 4, times it by 4. So now, that's crazy adding all these fractions. We're going to do 9/4. And then 2 times 9 is 18/4, so minus 18/4. But then 10 times 4 is 40, so that'll become 40/4. Wow. Okay, so then we have 40 minus 18. So what's that? 22/4? Or you could just do 9 minus 18 is another negative 9/4. So those kind of cancel out there, right? And then we want to do 40 minus 9. So 40 minus 9 is 31. That's wicked. So 31/4. Wow. 31/4 is our vertex. That's evil. So then 31/4, divide that and get a decimal there. This is the worst ever. Definitely use your calculator for number 10. This is wicked evil. Okay, so 31 divided by 4ths is 7.75. So we're going to go back 1.5 and then down 7.75. That's so evil for our vertex. Well, let's see if factoring was easier to find the x-intercepts. So we'll go and factor it. And so we'll go and get x and x. And then factors of 10 are 2 and 5. And then since the middle term is positive, you want the bigger number to be positive. So that's positive 5, negative 2. And 5 minus 2 is 3. So that does work. That's the correct factoring there. Yep. So now opposite signs. Remember opposite signs because you have to set each one equal to 0. So now we're going to do x equals a negative 5. So negative 5 is one of our x-intercepts. And add 2 to the other side, so a positive 2 is our other x-intercept. And there's our parabola. Bam! So you can always double check it by using your graphing calculator or using Desmos. So we'll go y, let's turn off the statistics there. Okay, so we'll go y equals, again, it was x squared plus 3x minus 10. And then we'll go ahead and do zoom standard, which is zoom 6. And, ooh, there it is. Now I can't fully see it because for some reason it goes off the charts there. Whoa, 31. What was 31/4 again? I thought it was only 7.75. That's interesting. Interesting. I thought we'd be able to see if I did the window, negative 10 to 10. You should be able to see that sucker, so that's really strange. Let's see. Wow. Negative 12. There it is. Huh. So is it saying our vertex is a little bit different? What happened? Let me see. So y equals, so we got x squared. Oh! No, that's right. X squared plus 3x. And then minus 10. So definitely we have the x-intercepts right at 2 and negative 5. But I'm wondering about the vertex, right, at negative 1.5. So second calc value. So isn't it negative 1.5? 12.25? What happened there? Made a mathematical mistake already. Dang it. Let's see. So I plugged in negative 3 halves. Let's try the calculator, right, and see what happened there. Because I had 9/4. So 3 halves squared. Oh, it was, no, that's right. So 3 halves. So 3 times 3 is 9 halves. And then negative 10/4 would be negative 40. So that'd be negative 9/4. And then 10 minus 9. I don't know. I feel like that's right. Okay, well, let's try it this way then. So we'll go ahead and do, let's see here. So we're going to do, so our negative 3 halves. We'll just call it negative 1.5 all squared plus 3 times your negative 1.5 and then minus 10. Oh, it's a minus 10. That's why. Okay, so it's okay, everybody makes mistakes. Everybody has those days. So this is supposed to be negative, this is supposed to be negative, and then for some reason I made it positive. What the heck happened there? So that's supposed to be negative. Nice. So now we're going to take negative 9/4, and we're going to go to minus another 40/4. And so that's going to give us a negative 49. This is the worst problem ever. So negative 40 and the 9/4 there. And so let's double check the negative 40, 49. Force, that should give us that 12.25. There it is. So it just means we have to go even further. What the, off the chart? Negative 9, 10, 11, 12. Worst problem ever. Okay, there we go. Wow, that's an evil one. Okay, they're not that bad. I promise they're not that bad. So really quick, for example, this is negative b, so negative 4 over 2a, which is just 2. So this would be just a negative 2 for the vertex, and when you plug it back in, negative 2 squared is 4 minus 8 plus 3. See, that one's not too bad. That's 7 with the negative 8 is the negative 1. So back 2 down 1. How easy was that? And then if you factor that sucker, it factors into what? 3 and 1, and both positive, and then you switch the sign, remember, so you get x equals is actually a negative 1 and a negative 3, so that's going to go here and here. See, so that, and then we'll just try that one real quick. So x squared plus 4x plus 3. And we'll hit graph, and there it is, not too bad. Okay, so there's some parabolas there, beautiful. Last but not least is going to be our beautiful exponential growth. So for example, this one, so you want to do an xy table, and you want to get the y-intercept by plugging 0 in for x, right? Every single time, y-intercept, plug in 0 for x. So when you do that, you get 2 to the 0 power, which is just 1. And then 2 times 1 is 2. So there's that one. Over here, plug in a 0, 1.5 to the 0 power, still 1. And so that one will just be negative 4 times 1 is just negative 4. Cool. And then at this point, I'd use my calculator or Desmos, but you could just plug in values to the left and to the right. So maybe like negative 2 and positive 2. That'd be easy. Okay, so we'll plug in a 2 in there. 2 squared is 4, and 4 times 2 is 8. So that's going to go ahead and launch over 2 up 8. So this is exponential growing. And then if you put a negative 2 in there, so 2 to the negative 2 power, wow. So 2 to the negative 2 power is going to flip it. So it'll be 2 times, and then 2 to the negative 2 is the same as 1 over 2 to the positive 2. So the negative in the exponent flips it and puts it in the bottom, right? So 2 squared go in the bottom. So that's basically going to be 2 squared is 4. So but it's in the bottom. So it's 1 over 2 squared is 4. And so then 2 times that will just be 2 over 4, which is just a half. Nice. So that'll be a half. And so we go back 2 and then up a half. And because there's no number in front of this equation, right, it's just a plus 0, then your asymptote will just be along the 0. Otherwise, you'd shift up 1 or shift up 2. So there's number 17. So you try 18. And then I'm guessing probably that 15 and 16, are we guessing that's decay? What do you think? Okay, so this is going to be under graphing right now. We're graphing. Preview. Here we go. Okay, Desmos. So we're going to do y equals parenthesis. Wait, there was a number before the parenthesis, I think. Let's take a look. So it was 4 and then 1/4 to the x power. So we're going to go ahead and do 4. And then 1 divided by 4. Right arrow again. Then parentheses. Cool. Can you see that? So there it is. And then we're going to do this, a to the b power, and then do the x. Okay? So it's 4 to the 1/4 power. It is decay. Look at that. And so it's up here at 0, 4 is where it crosses, and then it decays. So that's going to be 4 times 1/4 to the x power. So it's going to be right here, and then it's going to come down, and it's going to go ahead and decay. So there's number 16. Thanks for watching. Hope this helped you on the graphing homework assignment. Thanks for acing it. Peace out.